Hey there, friends. Today we're going to do some more work on the unit circle in radian measures. And so we're going to start by filling out a blank unit circle to help us in today's lesson. So if you're in class, you have one at your desk. If you're at home, you're going to have to print one out. And so you're just going to start by saying that this is 0 degrees or it's 0 radians. And then you're going to move up, and this is 30 degrees, which is pi over 6. This is 45 degrees or pi over 4. And this should also be on yesterday's check your understanding. 60 degrees or pi over 3, and 90 degrees or pi over 2. So continue on with that. Pause the video when now and continue doing that. So when you're finished, it should look something like this. So check your answers really quickly. Make sure yours looks like this if you have any mistakes. And notice the patterns here, right? So when you are doing this, noticing the pattern here, that, you have pi over 6, and then you go another 30 degrees, and this is the same as 2 pi over 6. Which is pi over 3. This is the same as 3 pi over 6. So you can count all the way around 4 pi over 6, and then you get back down here to 5 pi over 6. So you can just count your way around the unit circle. Similarly with the pi over 4. If I was looking at pi over 4 here, I could think about this pi over 4. This is the same as 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then we would be back to 8 pi over 4 over here. So just seeing the patterns in the unit circle. You don't have to memorize the unit circle, but recognizing the patterns is really helpful. Okay, and then we're going to get into today's lesson, which is looking at the wheel of algebra, which if you're here at school, you have it up on the board. If you're at home, it's on the Google Classroom. So you're going to be looking at this and realizing that each of these is at pi over 3. So this is pi over 6, sorry. Oh, let's write in something that's a little bit better. This is going to be 2 pi over 6 or pi over 3. So they're in 30 degree or pi over 6 increments, FYI. And we're going to use that wheel of algebra to work on this first sheet here. So go ahead and pick somebody in your group to be the reader, and you should be able to work through this whole thing using that unit circle that you filled out as a reference to answer all the questions. So go ahead and pause the video, and then I will go through and do teacher notes and go through it. Okay, well, welcome back. Hopefully you were able to do all of this straight through. So you drew the reference angle. I'm sorry, not the reference angle. You drew the angle and realized that it was 5 pi over 3. So you went through here. The next one, you noticed that it was a full rotation, so you needed to subtract away. And it's instead of subtracting away 2 pi, it's easier to subtract away 2 pi in some version of that's helpful for your subtraction. So plus or minus 2 pi, in this case it was 6 over 3, it might be 12 pi over 6 or 8 pi over 4, depending on what you're using. So coterminal angles are always plus or minus 2 pi. When we're dealing in degree measure, it's plus or minus 360. For radian measure, it's plus or minus 2 pi. Okay, so get that down, please, in your notes. And then with the next one, what we notice is that if we went around 5 pi over 4, we know that we're just a little bit farther off from the x-axis. And here again, you think about this x-axis as pi, but a better way of thinking about it is rewriting it as 4 pi over 4. So then when you think about how far away you are, you're only pi over 4. So again, your reference angle is the distance from the x-axis. So you're either going to be at 0 pi, 1 pi, or 2 pi. When we were looking at degrees, you were at 0, 180, or 360. But now we are thinking, we're not going to think about that in this way. We're thinking about that in radian measures. And that's what we're trying. I know it's, you're going to want to do that, is to think about this in degree measure, and that's okay. But eventually, hopefully, you'll recognize the radian measure. Okay? And then the last question asked about two possibilities. And what I did here is I wrote out all the different possibilities. And I looked at the x-axis as either 6 pi over 6, 12 pi over 6, or 0 pi, and then looked at the distance there. So if I'm only pi over 6 away, I subtracted or added. Here I would have subtracted pi over 6. Here I would have added. Here I would have added to 0. And here I would have subtracted away from 12 pi over 6 to get the 11 pi over 6. So you label the x-axis as a fraction with the denominator of 6, and then subtract away. All right. So again, here, when Macy the angle she made had a sine equals -1/2. Now, I told you not to put the all the measurements on just for time, but you could use that unit circle, the one that we had from before, and look back at your places where you had a sine of -1/2, and where that was at these two values over here, where your sine would be -1/2. That means your y value is -1/2, and on the unit circle, that happens at 7 pi over 6 or 11 pi over 6. All right, so now what I'd like you to do in your groups is pause the video and read through the learning targets, and then come back to get the teacher notes. All right, so first learning target was about coterminal angles. And as I said before, we've already done this with degrees. Now we're just doing the exact same thing with radians. So you already know half of it. You understand what a coterminal angle is, hopefully. And in radians, you're in degrees, you added plus or minus 360. Here we're adding plus or minus 2 pi. And you want to write the 2 as a fraction with the same denominator. So maybe it's 4 pi over 2, or 6 pi over 3, or 10 pi over 5, depending on what your denominator is. You always want to do that. Okay? So that's the first thing with coterminal angles. Pause the video if you need some time. Otherwise, I'm going to go to the second learning target. The second learning target was about reference angles. So let me see if I can... reference angles. And a reference angle is your distance from the x-axis. So we're going to label the x-axis as either 0 pi, 1 pi, or 2 pi. And you're going to do the same thing that you did before. You're going to write it as a fraction with the same denominator as the angle, and then either add or subtract as needed, depending if you're above it or below it. The last learning target was about the unit circle, to find the cosine, sine, or tangent. When theta is in radians, we're going to use the unit circle and find the xy values. So now would be a good time for you to go back to that unit circle and just write in those values. And notice the progression too. With the x values, it starts out at 1, 0, and then your x values get smaller and smaller because your x's are going in. Your y values are increasing because you're going up to the x-axis. Let's go back and check that out on the unit circle. So pause the video, fill in that unit circle. So what I was talking about is that you notice here that your x's, you start over here at 1, and then your x's are decreasing. Your x values are getting smaller. So you go from 1 to rad 3 over 2, rad 2 over 2, 1/2, then down to 0. Your y values, on the other hand, they start at 0, but then they're increasing, your y values. So your y value starts at 0, but then it starts growing. 1/2, rad 2 over 2, rad 3 over 2. This is, remember, rad 4 over 2, if you want to see that pattern. And then it's the exact same pattern in the other way, except that now my x's are negative, or my cosines are negative, my y's or my sines are positive. So understanding where x's and y's are positive and negative on your unit circle is also helpful. All right, so pause once you've got that all filled in, pause the video, do the check your understanding, and then come back and we'll go over those really quickly. So taking a look at the check your understanding, all we're doing is sketching the angle 7 pi over 8. So we wrote out the x-axis as 8 pi over 8 here, and then we just subtracted 7 pi over 8, and that's where we got the reference angles of pi over 8. Here with 5 pi over 3, I know I went beyond 3 pi over 3, and 3 pi over 3, I know 4 pi over 3 on my unit circle is over here, so 5 pi over 3 is going to be over here, and all the way around here, and so I needed to subtract that away from 6 pi over 3, so my reference angle was just pi over 3. Coterminal, I'm just adding 2 pi to each of these, but I'm doing it with 8 as a denominator, so that's going to be 16 pi over 8. For the other one, I needed 3 as a denominator, so I'm going to add 6 pi. And if I wanted to have a negative angle, I would have just subtracted away 16 pi over 8 to get a negative angle. And then for these, where sine 3 pi over 4, you can use, again, look at your unit circle to figure out where that is going to be. Your y value is rad 2 over 2. So that's your sine of the 3 pi over 4 angle, and that's going to be positive because the y is positive in the second quadrant. For cosine of 11 pi over 6, again, that's in the fourth quadrant, and in the fourth quadrant, your x values are also positive. So again, using your unit circle. All right, my friends, I hope this was helpful. This is just getting used to a new way of measuring angles. You're so used to measuring things by degrees. You feel pretty comfortable with that. Now we want to start feeling comfortable about measuring things in radians. All right, my friends, good luck on your homework tonight.